recorder going here. There we go. Let's take a look at properties of the trig functions. And we're going to be using the unit circle again. So refresh your memory. I found a different one, a better one, than the previous section. At least I think it is. We got 30 degrees, 45, 60. Then pi over 6, pi over 4, pi over 3, and then we got these values. Remember the pi over 6, square root of 3 over 2 and 1/2. And then the pi over 3 is reversed, 1/2 and then square root of 3 over 2. Now, depending upon which quadrant it's in, the signs will change, but other than that, there's symmetry. Like if I go to pi over 3 and I go straight over to 2 pi over 3, these values will be exactly the same, just the signs will be different. If I go to the pi over 6 and I go straight down to the 11 pi over 6, again, the values of the point will be the same except for the signs. So signs is the only thing you really have to be concerned with if you know the first quadrant. So if you get that down, then there's really not a real big issue there. We talked a little bit about this in the last section, but our trig functions are periodic. If we got sine, cosine, secant, and cosecant, then basically they start repeating after 2 pi. So I'm going to put down what we can do. We can add or subtract 2 pi or 360 degrees and get the same values. And that's kind of just common sense when you look at the unit circle. Like pi over 3. We've got 1/2 and square root of 3 over 2. Nowhere in here do you see 1/2 and square root of 3 over 2, except for in this one place. So to get back to those same values, I'm here at pi over 3. I can add 2 pi, go all the way around, and then I'm back to where I was. Or I tend to think of radians. Radians for me is easier for some reason, but 360 around. Now, tangent and cotangent are a little bit different. For example, let me pick an easy one so I don't have to write anything aside here. Pi over 6. Okay, I'm lying to you. Okay, let's try again. Pi over 3. Tangent is y over x. And if I put square root of 3 over 2 over 1/2, I get square root of 3. But if I go straight across, distance of pi, not that I can go straight across, but I get down to here. I got negative 1/2 and negative square root of 3 over 2. Well, tangent, y over x, if I put this negative square root of 3 over 2 over negative 1/2, the negatives cancel, the 2's would cancel, and I'd have square root of 3 again. So for tangent and cotangent, you don't have to go all the way around 2 pi. I mean, you can. That'll give you the same value, but specifically for tangent and cotangent, you can add or subtract pi or 180 degrees and get the same values. And when we get to the graph, we're going to see why that is. As these values are special that way. So let's look at our first problem here. We've got cosine of 570 degrees. It says, use the fact that the trig functions are periodic to find the exact value of each expression. Do not use a calculator. Well, 570 isn't in our unit circle, but we said for cosine we can add or subtract 360 degrees and get the same values. So on this one, we can take the 570 degrees minus 360. Excuse me. And is that 210? So 210 degrees. Well, now if I look on my unit circle, 210 degrees is right here. And remember, cosine is our x part. So x part would be negative square root of 3 over 2. Let me put these over here just in case you don't remember those. Cosine of whatever angle. This is for the unit circle, specifically. Cosine is equal to x. Sine is equal to y. Tangent is equal to y over x. Secant is 1 over x. Cosecant is 1 over y. And cotangent is equal to x over y. So again, I went to 210 degrees, which is right here. And cosine, we said, is equal to the x part of that point. So at 210 degrees, the x part is negative square root of 3 over 2. Let's take a look at our next problem. Cosecant 11 pi over 4. If I look on my unit circle, there is no 11 pi over 4. Looks like the highest denominator with 4 is 7 pi over 4. So, but cosecant is periodic, we said, so we can subtract 2 pi. Now I'm subtracting because I'm trying to get it into the unit circle. And if I look at the mixed number on this, 4 goes into 11 2 times, so it's greater than 2 pi. So that's why I know I have to subtract 2 pi. Now this is a mixed number. If you recognize that, that'll save you some headaches. What you do is you take a negative 2 pi times 4 gives you negative 8 pi, and then you add 11 pi, and that gives you 3 pi over 4. You will find a lot of things. I'll say that, well, they're in a mixed number form, where we can use that little trick. Again, I took negative 2 pi times 8 gives us negative 8 pi, plus 11 pi gives you 3 pi. Then your denominator stays the same. 3 pi over 4. Well, that is on our unit circle. And why did that turn green? I don't know. Okay, so I got 3. It did that yesterday. 3 pi over 4. Well, cosecant was 1 over y. So we're going to put 1 over and then the y part of the point at 3 pi over 4. So 3 pi over 4, the y part is square root of 2 over 2. Now, if you got a single fraction down below like that, you can flip it and multiply times your top part. Flip it, take reciprocal, which then gives us 2 over square root of 2. We can't have a square root of 2 downstairs, so multiply top and bottom by the square root of 2. And we get 2 square root of 2 over 2. Remember, when the square roots are the same, you multiply them together, they just kind of cancel out and just gives you that number. Now the 2's cancel, and our answer is square root of 2. Let's look at problem number 3. Got cotangent 23 pi over 6. Now if I took 23 divided by 6, gives me 3 pi, something like that. I don't care the exact value, I just want to know whether to add or subtract 2 pi. Well, in this case, I'm going to subtract 2 pi. So I got 23 pi over 6 minus 2 pi. Again, this is a mixed number, so you can do it mixed number format, or just rewrite this as 12 pi over 6, and then work with that. But anyway, I'll take negative 2 pi times the 6 gives me a negative 12 pi, and then I'll add a 23 pi, and that should give us 11 pi over 6, I believe. Yeah. Well, this is actually in our unit circle now. So if I come over here, 11 pi over 6 is right here. Recall, since I don't got it up on the screen right now, cotangent is x over y. So, at 11 pi over 6, our x is square root of 3 over 2. Our y is negative 1/2. Now, when you got remember when you got a single fraction over a single fraction, the denominator is the same like this, so the 2's will cancel. Basically, multiply the top and bottom by 2. So we're going to have square root of 3 over negative 1, which just gives us negative square root of 3. And that's our answer. Now these next ones revolve around quadrants and their signs. So let's talk about that. First off, just to refresh your memory in quadrants. You see them early on in algebra, but you really don't do much with them. In trig, they're very important. This quadrant right here is your first quadrant. This is your second. This is your third. And this is your fourth. It's always in Roman numerals. Goes counterclockwise. Now, if I look at a point in my first quadrant, doesn't matter which one we'd look at. We got a x comma y. Well, the x is going to be positive here, and the y is going to be positive. Now, if we look at a point over in our second quadrant, the x is going to be negative, and the y will be positive. If we look in our third quadrant, the x is negative, and the y is negative. And if we look in our fourth quadrant, the x is positive, and the y is negative. We're going to use those to help us tell some information about these next problems. So we got sine theta is less than 0. Cosine theta is less than 0. Now, going back to our formulas up above, cosine is our x, and sine is our y. So we could think of, instead of sine theta, we can think of y as less than 0. Well, that's saying y is negative. This one, instead of putting a cosine in there, we can think of x. X is less than 0, which means x is negative. Well, if I look at my quadrants here, where y is negative and x is negative, is quadrant 3, which is what they're asking. They're asking which quadrant that'd fall into. Name the quadrant in which angle theta lies. So that'd be our answer. Let's look at this next one. We got secant theta is equal, or not equal, secant theta greater than 0, and tangent theta is less than 0. Now, secant. Remember, secant is tied to cosine, so secant is going to be 1 over x, and tangent is going to be y over x. Now, if I think of this right here, 1 over x, the 1 really does not matter. 1 is always positive, so it doesn't affect it. When I say secant is greater than 0, that's basically saying that x is greater than 0, so x is positive. Because if x was negative, like if I put a negative 2 in for x here, we'd have negative 1/2, which is not greater than 0. So that's the same thing as saying x is positive. Now in this one, tangent is less than 0. So tangent is negative. So tangent is negative, and which is saying that y over x is negative. Well, if we think of the different possibilities we have for this, think what gives you a negative number first. You could have like a positive number on top, negative on the bottom. That would give you a negative. You could have a negative on top and a positive on the bottom. That would give you a negative. Now, if I had a positive on top and positive on top, that's positive. If I had a negative on top and negative on top, negative divided by negative is positive. So the signs have to alternate like this. Well, let's think of this. Say this is y, this is x. So here we're saying y is positive, x is negative. Y is positive, x is negative would be right here. This one, we're saying y is negative and x is positive. Y is negative, x is positive would be right here. Now, over here, we already said that x is positive. Well, x is positive in this quadrant and this quadrant. So where they're both true, it's quadrant 4, which would be our answer. So again, you kind of look where they're both true. For tangent, I did this little number and found the circles. That's where tangent's negative. And for secant, being positive, x is positive, it's in these two quadrants. So where they're both true is here. Let me save that. And let me see. Properties of the trig functions. Properties of the trig functions. Take a look at our next problem. So we got sine theta is equal to negative square root of 22 over 5, and cosine theta is equal to negative square root of 3 over 5. Now this is actually giving us something on unicircle. If I were to square these and add them together, they give me 1. So for a unicircle, remember our formulas. Cosine of our angle is equal to x. Sine is equal to y. Tangent is equal to y over x. And not that you need them. Secant is equal to 1 over x. Cosecant is equal to 1 over y. And cotangent is equal to x over y. Okay. Well, this here would be our y, and this would be our x, based upon that. So let's find tangent. I think it's to find the other 4. Find the exact value of each of the 4 remaining trig functions. Okay, so tangent is equal to y over x. Y we said was negative square root of 22 over 5, all over x, which is negative square root of 3 over 5. Now, we got a single fraction over a single fraction, so remember that if you have the same denominator, they both have 5, those 5's going to cancel. The negatives will cancel. Negative divided by negative is positive. So we got square root of 22 over 3, square root of 3. Now, let me write that again. I kind of wrote that a little bit too sloppy. Okay. So we got square root of 22 over square root of 3. Can't have a square root downstairs, so we'll multiply top and bottom by the square root of 3. And we'd end up with square root of 66 over 3. And that's tangent. And remember, sine was negative square root of 22 over 5, and cosine is equal to negative square root of 3 over 5. Well, cosecant is sine flipped, the reciprocal of it. So this becomes 5 over negative square root of 22. Can't have a square root downstairs, so I'll multiply top and bottom by the square root of 22. I'll put the negative up on top. So I got negative 5 square root of 22 over 22. Secant is the reciprocal of cosine. So this will be 5 over negative square root of 3. Can't have square root of 3 downstairs, so I multiply top and bottom by square root of 3. I put the negative up on top. And I got negative 5 square root of 3 over 3. And then cotangent is tangent flipped, the reciprocal. Is there a good place to flip that, I wonder? Nope. Okay. So take this, and that gives us 3 over square root of 66. And again, cannot have a square root downstairs, so multiply top and bottom by the square root of 66. And we get 3 square root of 66 over 66. The 3 and 66 reduce. So I get square root of 66 over, both top and bottom divisible by 3, over 22. Now those are if it's on a unit circle. These next are a little bit different. So let me write down the formulas from what we saw before. If the point is not on the unit circle, and remember, we got a note up at top. R is equal to square root of x squared plus y squared. And we have cosine is equal to x over r. Sine is equal to y over r. Tangent is equal to y over x. Secant is equal to r over x. Cosecant is equal to r over y. And cotangent is equal to x over y. Okay, so in problem number 7, we have cosine theta is equal to 5/13. And theta is in quadrant 4. Now, first thing we're going to determine is determine the quadrant. Well, this one's really easy. They tell us this is in quadrant 4, so let's write down here. Second thing, we're going to find x, y, and r. Well, in this problem, they tell us cosine theta is equal to 5 over 13. And remember, cosine is x over r. So, x is equal to 5, and r is equal to 13. Actually, I guess we need the other formula, version of this formula too. Is that we got r squared is equal to x squared plus y squared. Didn't need that in the last section, but I guess we will need it here. Well, we have x, we have r, but we don't have y. So let's plug it into this formula. So x squared plus y squared equals r squared. X we said was 5, so we got 5 squared plus y squared equals r squared, which is 13. So 13 squared. So we got 25 plus y squared is equal to, I think 169 is what that is. Yeah. Take 25 over. We get y squared is equal to 169 minus 25. y squared is equal to 144. Drop the squared, put a plus or minus square root on the other side, and we get y is equal to plus or minus 12. Well, we can't have both. It's either a positive or negative. That's why we determined the quadrant up here in step 1. It's down here. Think what your y values are in this quadrant. They're negative, aren't they? So y is equal to negative 12. Then step 3. Use the formulas to find the trig functions. Well, we were given, what were we given? Cosine, so we don't need that one. Sine theta is equal to y over r. Well, y we said was negative 12, and r we said was 13. Tangent is y over x. Y we said was negative 12, and x we said was 5. Secant. Now you could do r over x, but really secant is just cosine flipped, so it's a lot easier to think of it that way. If I can get that up. Okay, cosine was 5 over 13, so secant will be 13 over 5. Cosecant. Well, sine we said was negative 12 over 13, so this will be 13 over negative 12. And cotangent is tangent flipped, the reciprocal of it, so this would be 5 over negative 12. And those would be our remaining trig functions, which is what they're asking here. Find the exact value of each of the remaining trig functions. Now we're going to use these same 3 steps to do the next problems also. So let me go ahead and save this. I won't write them down again. Okay. So number 8. Sine theta is equal to negative 1/6. And cotangent theta is less than 0. First step, determine our quadrant. Well, first off, let's take a look at cotangent theta is less than 0. Cotangent, remember, is x over y. Less than 0 means negative. So we're saying that is negative. Well, again, the only time you can get that negative is where the signs alternate. Like if I had a positive x and a negative y, so 5 over negative 2. Or if I had a negative x, like negative 3, and a positive y. These would both give you a negative number. So we're looking for where the signs are different. Well, here the x and y's are both positive, so that doesn't work. Here they're different. Down in the third quadrant, they're both negative, so that doesn't work. And here they're different. So those two are where cotangent is less than 0. Now this one tells us sine is equal to a negative number. Well, where sine is a y, so what y is negative is right here and right here. So the quadrant they both have in common is quadrant 4. So that's one we're going to be working with. I didn't need to circle that though. There we go. Okay. Now, sine theta is equal to negative 1 over 6. And from our formulas, sine is equal to y over r. So y is equal to negative 1, and r is equal to 6. Now, you know with a fraction, a negative can go on top, can go on the bottom, but we know r always has to be positive, so it's always going to go on top if you have an r involved. Let me see, x squared plus y squared is equal to r squared. Remember, step 2 is to find x, y, and r. Well, we know y and r, so let's plug those in. So we got x squared plus negative 1 squared is equal to 6 squared. So x squared plus 1 is equal to 36. Take the 1 over that. And which gives us 35. Drop the squared. Put a plus or minus square root on the other side. Now we can't keep both of those. But if we come up here, we're dealing with quadrant 4, and x is, you have to think of the sign. Down in quadrant 4, x is going to be positive. So, x is going to equal to a positive square root of 35. Again, yeah, quadrant's very important on these. It helps you determine what your sign is going to be. Now let me jot these down. Let's see, x we said was square root of 35. Y we said was negative 1, and r is 6. So now we're ready to find our remaining trig functions. Cosine. Cosine is x over r. So we're going to have square root of 35 over 6. Tangent. Tangent is y over x. Y is negative 1. X is square root of 35. Now we can't have a square root downstairs, so we'll multiply top and bottom by the square root of 35. So I get negative square root of 35 over 35. Cosecant. Cosecant is sine flipped. Sine was negative 1, 6. So this would be 6 over negative 1, or just negative 6. Secant is cosine flipped, the reciprocal of it. So that would give us 6 over square root of 35. Again, we can't have square root downstairs, so multiply top and bottom by square root of 35. We got 6 square root of 35 over 35. And cotangent. Cotangent is tangent flipped. And I'm going to flip the appropriate one. I'll pick this fraction here, the negative 1 over square root of 35. It's easiest. So we got square root of 35 over negative 1, which gives us negative square root of 35. And those are our answers. I think I have room for this. Next one. Secant theta is equal to negative 5, and cosecant theta is greater than 0. And find exact value. Okay. Step 1. Determine our quadrant. Well, secant is let me write this down. Secant is tied to cosine, which is x. So the r doesn't make any difference in that because r is always positive. So this is saying, basically saying x is negative. Well, x is negative here and here. Now cosecant is r over y, and again r doesn't really apply at all, so we're just dealing with y. So we're saying y is greater than 0. So we're saying y is positive. Well, y is positive here and here. Where they're both true is in quadrant 2. Well, step 2. Secant theta is equal to, and if you don't have a fraction, you can always create a fraction by doing this, putting it over 1. Now recall though, secant theta from our formulas is equal to r over x. Now r can't be negative, but I could equally take that negative and put it down below like that. So r is going to equal to 5, and x is going to equal to negative 1. Well, we're missing y, so we got x squared plus y squared is equal to r squared. X we said was negative 1, so we got negative 1 squared plus y squared equals r squared. Oops. Should plug in the r, I guess. R we said was 5, so we got 5 squared. So that gives us 1 plus y squared equals 25. Solving for y, so I take the 1 over, and I get y squared equals 25 minus 1. Y squared is equal to 24. Drop the squared, square root property. Drop the squared, put a plus or minus square root on the other side. Now 24 is 2, 4, 8, 24, like that. We're looking for a pair of numbers, so here's a pair of 2s, so that's going to come out, or a pair of anything, I should say. So we got y is equal to plus or minus 2 square root of 6. Let's look at our quadrant. We pick quadrant 2. Y is positive here. So, down here, our y we're going to be working with is going to be positive. So we have y is equal to 2 square root of 6. Okay, so let's find our remaining trig functions. Let me see. Let me write this down. X is equal to negative 1. Y is equal to 2 square root of 6. And r is equal to 5. Let's look at cosine. Cosine is secant flipped. This is not in fraction form, but I could put it as negative 5 over 1, and then it'd be negative 1 over 5. Or I could just use my formulas. So this is x over r, so I got negative 1 over 5. Sine is equal to y over r. So we got 2 square root of 6 over 5. Tangent is equal to y over x. Y we said was 2 square root of 6, and x is negative 1, so that gives us negative 2 square root of 6. Cosecant. Cosecant is sine flipped, so we got sine is this, so cosecant will be 5 over 2 square root of 6. Now I can't have a square root of 6 downstairs, so I'll multiply top and bottom by the square root of 6. And that gives us 5 square root of 6 over, square root of 6 times square root of 6 is 6, times 2 is 12. And then cotangent is tangent flipped. And this fraction here is probably the best. 2 square root of 6 over negative 1, so it becomes negative 1 over 2 square root of 6. And again, we can't have a square root of 6 downstairs, so multiply top and bottom by square root of 6. And that gives us negative square root of 6 over, square root of 6 times square root of 6 is 6, times 2 is 12. And those would be our answers. So let me save that. Get a drink also. Now these next problems revolve around the even and odd properties. They say use the even odd properties to find the exact value of each expression. So let's take a look at the formulas. Then we'll work some problems. These revolve around, if you remember from college algebra, where we had y is equal to x squared, and this was an even function. That was an even function. Basically, if you plugged in a negative 2 for the x, Negative 2 squared would give us 4. Or if you plugged in a 2 for the x, 2 squared would also give us 4. So it doesn't matter, that negative basically just disappears for an even function. And it's symmetric to the y-axis. Now, odd function, basically a negative would come out in front, if you remember. Cosine and secant are even. Now what that means is if you have cosine of a negative angle, that's going to equal to cosine of the positive angle. You can just drop the negative, just like what's said right here. If you have secant of a negative angle, you can just drop the negative. Now sine, cosecant, tangent, and cotangent are odd functions. We're going to see this when we get to the graphing. Which means if you got sine of a negative angle, you can take that negative and put it out in front, and then the angle becomes positive. And that's the same with all of these. So we got cosecant of negative theta is equal to negative cosecant of theta. Tangent of negative theta is equal to negative tangent theta. And cotangent of a negative theta is equal to negative cotangent theta. So let's look at this problem. We've got cosine of negative 60 degrees. Now, it says use the even odd properties to find the exact value of each expression. Obviously, negative 60 degrees isn't on our unit circle, if I look at here. Now, I could add 360, we've seen that. Or you could simply, remember that cosine's an even function, which means we can just drop the negative. So this becomes cosine of 60 degrees. Now, remember we come here, we go to 60 degrees. Cosine is our x part of our point, so our answer would be 1/2. Let's look at another one of those. We got tangent of a negative 120 degrees. Well, we said for tangent, if you got a negative inside, you can take the negative and put it on the outside. So this becomes negative tangent of 120 degrees. Now remember, tangent is equal to y over x. Now the negative just stays out in front. And we're going to go to our unit circle and we're going to look up 120 degrees and see what y and x are. So 120 degrees would be right here. Y would be square root of 3 over 2. So square root of 3 over 2. And x, what did I say? 120 degrees. Okay, x would be negative 1/2. Well, negative negative becomes positive, so those cancel each other out. The 2's would cross off, and we got square root of 3 over 1, which just gives us square root of 3. And that'd be our answer. Let's look at one more of those. We got cosecant of negative 2 pi over 3. Now again, I could add 2 pi to get into the unit circle, but I want to use my even odd properties. Cosecant was odd, which means we can put the negative out in front. So this becomes negative cosecant 2 pi over 3. And for our unit circle, cosecant is related to sine, which is y, so this will be 1 over y. Negative stays out in front. We got 1 over something. So let's go look at 2 pi over 3. 2 pi over 3 is right here. And sine, y at 2 pi over 3 is going to equal square root of 3 over 2. So I'll put that in. Well, again, if you have a single fraction downstairs, you can flip it and multiply times the top part. So the square root of 3 over 2 becomes 2 over square root of 3. Negative 1 times 2 gives us negative 2 over square root of 3. Can't have a square root downstairs, so I'll multiply top and bottom by square root of 3. And we get negative 2 square root of 3 over 3 as our answer. Now these next ones revolve around some properties. So let me put those up. Now remember, actually let me go ahead and write properties here. Our first one, tangent is equal to y over x. And we said that cosine is equal to x and sine is equal to y. Well, if I plug these in, we said y is equal to sine theta, then we're going to find tangent theta is equal to sine over cosine. We plug in these values. X is equal to this, so we plug the cosine here. Y is equal to this, so we'll plug sine in here. So that's our first. Tangent theta is equal to sine theta over cosine theta. Now we also said that cotangent theta is equal to x over y. So using the same logic, up here we said x is equal to cosine, so we'll put cosine in there. And we said y is equal to sine, so we'll put sine in here. So cotangent theta is equal to cosine theta over sine theta. Now, we said for your unicircle, we had x squared plus y squared is equal to 1. Well, up here we just said x is equal to cosine. So let me put cosine theta in for x. So we got cosine theta squared plus, and we said y is equal to sine theta, so we'll put sine theta in for y. So we got sine theta squared equals 1. Now, you don't write it this way. When you got a trig function squared, you take that squared and you put it right there. That says cosine squared, and if this is you have this squared, then you again do the 2 in like that. So that's our third property. Cosine squared plus sine squared is equal to 1. Now, starting with this formula here, I could divide everything by cosine squared. Like that. And then we got sine squared over cosine squared equals 1 over cosine squared. Well, cosine squared plus cosine squared is 1. Now, sine squared over cosine squared. Sine over cosine is tangent. And these are squared, so this would be 1 plus tangent squared. And 1 over cosine, if you remember from last section, we said was secant. So that's, and I'll write those up here again here in a second. So that's secant squared. So our fourth formula, we got 1 plus tangent squared is equal to secant squared. And if I go back to this formula right here, and I divide both sides by, or I divide everything by sine squared, we would have cosine squared over sine squared plus sine squared over sine squared is equal to 1 over sine squared. Now, cosine over sine is cotangent, so this would be cotangent squared plus sine squared divided by sine squared is 1 equals, and 1 divided by sine squared would give me cosecant squared. So this formula is cotangent squared plus 1 equals cosecant squared. Now we have some additional ones, the ones we went over last time. Those are the new ones here. We have that cosine theta is equal to 1 over secant theta. we have sine theta is equal to 1 over starting to write that wrong. Remember, cosine is tied to secant, sine is tied to cosecant. So 1 over cosecant. Tangent is tied to cotangent, so tangent is equal to 1 over cotangent. They're reciprocals of each other. And secant is equal to 1 over cosine. And cosecant is equal to 1 over sine. And cotangent is equal to 1 over tangent. When you think about it, secant. Secant is equal to 1 over x, and we just said x was cosine. So they kind of you can derive all of them. You just have to know a few basic ones to begin with, and then you can get the rest. Okay, let me save this. Unfortunately, I'll write the properties up here again, because we'll need it for the next problems. Okay. So let me write them up here. Tangent theta is equal to sine theta over cosine theta. Cotangent theta is equal to cosine theta over sine theta. Usually sine is written first, so I'll do that. Sine squared plus cosine squared is equal to 1. And I never have these memorized. I just derive in my head each time because it's so easy. If you divide everything by cosine squared, then you'd get tangent squared plus 1 equals secant squared. And if I divide everything by sine squared, I get 1 plus cotangent squared is equal to cosecant squared. Let's see. Then we have, I don't remember what order I did them in, but we'll say cosine theta is equal to 1 over secant theta. Sine theta is equal to 1 over cosecant theta. Tangent theta is equal to 1 over cotangent theta. These are ones you should know. You should be able to know or come up with fairly easy. Shouldn't have to refer to look these up. Secant theta is equal to 1 over cosine theta. Now that I've said that, I'll probably screw one of these up. Cosecant theta is equal to 1 over sine theta. And last one, cotangent theta is equal to 1 over tangent theta. I don't think I've forgotten any of the formulas, so let's use these now. So we got number 13. And we got cosecant squared 40 degrees minus cotangent squared 40 degrees. Well, they say to use properties of trig functions to find the exact values of each expression. Do not use a calculator. Obviously, I cannot look these up in my unit circle. 40 degrees is not on my unit circle if I were to flip over to it. So I come over here and I'm looking through these properties. I'm looking for one that has cosecant squared in it or cotangent squared, and actually we have one of them that has both. We have our fifth one. Fifth one looks like this. 1 plus cotangent squared is equal to cosecant squared. Well, that's not quite what this looks like, but I see if I take the cotangent squared over to the right side, like that, then you get 1 is equal to cosecant squared theta minus cotangent squared theta, which matches this. Cosecant squared minus cotangent squared. Now, the angles have to be the same, the theta, and they are. These are both 40 degrees. So cosecant squared minus cotangent squared is equal to 1. So you have to be flexible with these formulas. You have to, those properties, you have to be able to twist them every which way to try to get to match your problem. Let's look at this one. Number 14, we got cosine of 25 degrees times secant of 25 degrees. Well, obviously 25 degrees not on my unit circles. That can't help me. I'm going to see if I have a formula involving cosine and secant. Cosine and secant. Only one I have is this one right here, where I say cosine theta is equal to 1 over secant. Or secant theta is equal to 1 over cosine. Well, let's use number 9. So what that's saying is I'm going to leave the cosine 25 degrees alone. The secant 25 degrees I can rewrite as 1 over cosine at 25 degrees. And once I do that, then I can see that these cosine 25 degrees will cancel, and my answer is 1. Let's look at number 15. Tangent 220 degrees, cotangent times cotangent of 40 degrees. There's two different ways you could work this, but the important part is before I even start looking for formulas, these angles have to be the same. Well, if you remember, tangent is a periodic function. Specifically, you can add or subtract 180 degrees, pi. So for this first one here, I can rewrite the tangent 220 degrees. I can subtract 180 from it. Now, if I were to subtract 180 degrees, 220 minus 180 gives us 40 degrees. Now, what made me think that is, well, 220 was larger than 40, so I wondered, well, if I subtract 180, will they be the same? And they are. Now, from the 11th property, we said cotangent theta is equal to 1 over tangent theta, so I can rewrite the cotangent 40 degrees as 1 over tangent 40 degrees. And by doing that, then this cancels with this, and our answer is 1. I don't think all the answers are 1, in case you're wondering, but maybe they are. I don't know. Okay, so here we got cosine 50 degrees over sine of negative 310 degrees plus cotangent of negative 50 degrees. Well, I'd like these to be 50 degrees. Why? Why did I choose 50? No particular reason. Except for this one was 50 and this one was 50, so that looked like the easiest one to go for. Now remember, a sine is a periodic function, and we can add 360 degrees to that one. So this can become cosine of 50 degrees over sine of negative 3, let me erase that, negative 310 degrees plus 360 degrees. And this one's easy to get 50 degrees here, but this is negative, and we don't want to add or subtract anything. We remember that cotangent is an odd function, which means we can take the negative and put it out in front. So that becomes a minus cotangent of 50 degrees. Well, this gives us cosine of 50 degrees, and when I add 360, that's going to give me 50 degrees. Minus cotangent 50 degrees. Trying to simplify it, so I'm going to look for a formula that has cosine over sine. Cosine over sine. Well, that's the second one here. Cosine over sine is cotangent. So I can rewrite the cosine 50 degrees over sine 50 degrees as cotangent 50 degrees. And I'll bring down the minus cotangent 50 degrees. And now cotangent 50 degrees minus cotangent 50 degrees is 0. And that's our answer. And I think that's the last problem. Yep, last one. So let me find my recorder and stop it. And then stop the other recorder. So F10.